Welcome back, Apologia, 8th grade, Physical Science, Week 12, Day 3, textbook pages 193 to 196, notebook pages 152 through 156. Speed and velocity. If an object is in motion, its position is changing. Over time, that will result in a certain distance over which the object travels. This is called the object's speed. You've likely heard the term velocity used in this way too. In everyday conversation, you probably use the terms speed and velocity interchangeably. In physics, however, there is a big difference between speed and velocity. Just like displacement contains more information than distance, velocity contains more information than speed does. Speed tells you how quickly an object moves in relation to a reference point. Velocity tells you how quickly and in what direction the object is moving in relation to a reference point. By now, you should appreciate how including directional information can make a big difference when giving someone directions. Directional information is also important in talking about velocity. You will learn much more about the difference between speed and velocity when you take physics in high school, but we'll get a good foundation now, so let's talk about speed first. Speed is described in units of distance and time. The SI unit of speed is meters per second, but other common units of speed are kilometers per hour, or in the English system of units, of which you guys are probably most familiar with, feet per second, miles per hour. Just as with distances, you need to choose units that make the most sense for the motion you are describing. And, as is true with all measurements, you must keep the units with the number, or the measurement will not make sense. You can measure the speed of a moving object by measuring the time it takes for the object to travel a certain distance. For example, you can measure how long it takes someone to bike 50 meters. Or you can measure how far the person can bike in a certain time, such as 10 seconds. In either case, the speed will be the ratio of the distance traveled to the amount of time it takes to travel that distance. We can write that mathematically as speed equals distance over time. Remember, the word per means divided by, so when we say that speed is 10 meters per second, it means 10 meters divided by 1 second, or 10 meters per second. You should also know that many physicists use the letter V as a symbol for both speed and velocity. In this course, we will use V to symbolize velocity too, but remember that velocity requires direction, while speed does not. There are two ways to express the speed of an object: average speed and instantaneous speed. Average speed is the ratio of the total distance traveled to the total time of the trip. Instantaneous speed is the rate at which an object is moving at a given moment in time. When you ride your bike, do you travel the same speed all the time? It's not very likely that you do. You may go slower when you bike up a hill and faster as you travel down the hill. This means that your speed is not constant. Because speed is not usually constant, we find how fast something moves for the entire trip. This is called the average speed, and it is the total distance traveled, divided by the time it takes to travel that distance. Sometimes, though, you need to know exactly how fast you are going in a particular instant. For example, when you're driving on the highway and the speed limit changes, it's important to know how fast you're going in that moment so you can adjust your speed accordingly. The speedometer in cars gives the instantaneous speed. During the time an object is moving, its instantaneous speed may change, but you can find the average speed over the entire trip using equation 6.1. Study the following example problem to see how this is done. Pay particular attention to the steps to solving physics problems, as you will need to do this in the following modules as well. Then, practice what you learned by completing the on-your-own problems that follow. Okay, example 6.1, notebook page 152. A car travels 78 miles down the highway. It takes the car 1.2 hours to travel that far. What is the average speed of the car? Step 1. List the information that is given to you in the problem, and then list the unknown, or what the question is asking you to find. So it told us the total distance was 78 miles. So D is 78 miles. The total time, T, is 1.2 hours. And we do not know, and we're looking to find the average speed, V. Step 2, write out the equation that you will use. V equals D over T. Step 3, write out the equation substituting the numbers from the list in step 1. So we substitute D, 78 miles, and T, 1.2 hours. So we have velocity, or the speed, equals 78 miles divided by 1.2 hours. And the last thing to do is actually just solve the problem. So when you divide out 78 miles divided by 1.2 hours, you get 65 miles per hour. Example 6.1, notebook page 152. What is the speed of the car from the previous problem in meters per second? And it tells us that 1 mile equals 1,609 meters and 1 hour equals 3,600 seconds. So again, step 1, list the information that is given to you, then list the unknown. So once again, we know the distance and the time. We're looking to find the speed. Step 1B, convert any quantities using the given conversion factors. This goes back to Module 1, where we have to convert miles into meters, and we know that 1 mile is 1,609 meters. So we get rid of the miles, and then we multiply 78 times 1,609, and we get 125,502 meters. So now we know our distance in meters. We have to convert hours into seconds. 1.2 hours times 3,600 seconds is 4,320 seconds. So now we know our time in seconds. So step 2, write out the equation you will use. Speed equals distance over time. Step 3, write out the equation substituting the numbers from the list in 1B. So we figure out what our distance was and what our time was, and we substitute that into our equation. And then the final step is actually to solve the problem. Divide 125,502 meters divided by 4,320 seconds. The answer, which we have rounded, was 29.1 meters per second. If you do the calculation with the calculator, as you should, you will notice that the answer is 29.0513889. I rounded that to 29.1. When you take high school chemistry and physics, you will learn about significant figures, which will tell you when and where to round a number off. For this course, do not worry too much about rounding a number. Your answer will be right even if you round off at a different place than I do. Now realize that 29.1 meters per second and 65 miles per hour are both the same speed. They simply express that speed in different units. That is why it is so important to keep your units in any equation that you use. All right, on your own. What is the average speed of an aircraft that travels 115 miles in 30 minutes? Put your answer in units of miles per hour. Step 1, list what is given and what is needed. We know the distance, 115 miles. We know the time, 30 minutes. And we're looking to find the speed. Now, we have to convert. So step 1B is convert any necessary units. Once again, we know 30 minutes, it's 115 miles in 30 minutes, and we want to find the answer according to miles per hour. So we have to get rid of our minutes and convert that into hours. So 30 minutes is a half an hour. Step 2, write the equation that we're going to use. Speed equals distance over time. Step 3, plug in the quantities from 1a and 1b into the expression. So we have our distance and we have our time. We solve the problem and we get our speed as 230 miles per hour. On your own, 6.4. When measuring the speed of a snail, a good unit to use is millimeters per minute. A snail takes all day, 12 hours, to travel 5 meters. What is the average speed in millimeters per minute? All right, step 1, always list what is given and what is needed. We know the distance is 5 meters. We know the time is 12 hours. We are trying to solve for the speed. Well, are there any conversions? Yes. So step 1B, convert any necessary units. We need to convert our 12 hours into minutes. So 12 hours is 720 minutes. We need to convert our meters into millimeters. So 5 meters is 5,000 millimeters. Step 2, write the equation that we're going to use. Speed equals distance over time. Step 3, plug in the quantities from 1a and 1b. We know that 5,000 millimeters is our distance. 720 minutes is our time. So when we solve the problem, we get 6.9 millimeters per minute. And lastly, 6.5. While traveling on vacation, you measure the times and distance between stops. You travel 48 kilometers in half an hour, followed by 64 kilometers in 0.7 hours. What is your average speed in miles per hour? Hint, remember the average speed is the total distance divided by the total time. So, step 1A, list what is given and what is needed. All right, our distance, we have 2. We have 45 kilometers and 64 kilometers. They shouldn't have said 48. So we have 109 kilometers. Our time is 0.5 hours and 0.7 hours. So that's 1.2 hours. We're trying to solve for our speed. Convert any necessary units. We have to convert kilometers into miles. So we know that 1 mile is 1.61 kilometers. So when we get rid of our kilometers, we get 67.7 miles. Write the equation that we're going to use. Speed equals distance over time. Plug in the quantities from 1A and 1B. So we go back up here. We have our distance, 67.7 miles, and we have our time, 1.2 hours. And step 4, solve the equation, 56.4 miles per hour.